Assalamualaikum and good day everybody. My name is Amar Rafiq Beramno and my card matrix is 01DEE24F1040, and today I'll be presenting about environmental control strategies for coal-fired power plants under the subject DET30143 power system. Coal-fired plants are one of the main energy sources in Malaysia and many other countries. However, this method produces a lot of pollution which is affect both the environment and human health. So today I explain how we can reduce this impact while still supporting sustainable development goal 7, affordable and clean energy. Moving to the next slide is a coal-fired power plant release many type of pollution. First, air pollution. Gas like carbon dioxide, sulfur dioxide and nitrogen oxide are released into the atmosphere. Second, thermal pollution, which happen when the hot water from the cooling system is discharged into our river. Third, solid waste pollution from ash and other combustion byproducts. And lastly, high water and energy consumption throughout the process. All of these issues must be managed carefully to make the system more sustainable. For the next slide is about proposed environment control methods. To reduce pollution, we can apply environmental control strategy to different parts of the plant. For example, emission stack. We can use electrostatic receptors or fabric filters to trap dust and fine particles. For ash disposal, we can implement ash recycling system where ash is reused in cement or road construction. For cooling water system, we can install cooling towers or heat exchangers to control temperature before discharging the water. And for the combustion process is we can use flue gas, desulfurization and low nitrogen dioxide burners to remove sulfur and nitrogen gases before they escape. For the next slide is about block diagram explanation. This slide shows a simplified block diagram of the system power plant together with a proposed environmental control system. Let me explain how each stage works in sequence. First, the process begins with the coal combustion inside the boiler. The burning of coal produce hot gases and steam. The steam drives the turbine, which is connected to the generator to produce electricity. However, during this process, large amount of flue gases and ash are released. To reduce air pollution, the flue gases first pass through an electrostatic receptor or fabric filter system. This device removes fine dust particles and smoke before the gases are released into the atmosphere. After that, the gases move into the flue gas desulfurization unit, also called the scrubber, which remove harmful gases like sulfur dioxide and nitrogen dioxide. The clean gas is the release through the emission stack, minimizing air pollution and improving air quality around the plant. Next, the ash collected from bottom of the boil and SP is sent to ash handling and recycling unit. Here, the ash can be safely restored or reused or as a raw material for cement, brick or road construction, reducing solid waste and promoting circular economy practice. For a cooling system, the steam after passing through the turbine is condensed back into the water using a cooling tower or heat exchanger. This helps a lot for control the temperature of the discharged water by preventing thermal pollution to nearby rivers or lakes. The cool water is then reused in the cycle, which also saves the water resources. In summary, this block diagram shows us how each control system, including ESPs, scrubbers and ash recycling and cooling towers, ensuring that electricity generation continues efficiently. By integrating all these technologies, we can create a sustainable coal-fired power plant that support both energy production and environmental conservation. Moving on to our next slide is about comparison ESPs versus fabric filters. Now, let's compare two main filtering system electrostatic receptor. and fabric filters, also known as backhoe filters. Electrostatic precipitors can remove about 99% of fine particles, and they have a low maintenance cost once installed. Fabric filters, however, are slightly more effective, up to 99%, but they need regular filter replacement. In terms of complexity, ASPs need high voltage equipment which fabric filters are simply to operate environmentally. Electrostatic precipitator or ASPs produce less solid waste, while fabric filters generate used filter bags that must be disposed of properly. Moving to our next slide, about comparison between wet versus dry scrubbers. Another comparison is between wet scrubber and dry scrubber. Wet scrubbers use water and chemical remove gases like sulfur dioxide and dust, but they produce wastewater sludge. Dry scrubber can be used also for dry materials, making them cleaner and easier to handle, to slightly less effective. Wet scrubbers are more expensive to run, while dry scrubbers are more affordable and environment friendly. For the next slide is about relation to SDG 7. This solution contribute directly to sustainable development. Goal 7 is about affordable and clean energy. By using efficient filtering and recycling system, we reduce emission, lower waste, water waste, and make power generation more sustainable. Cleaner plants mean healthier communities, reduce environmental impact, and long-term cost saving for the energy sector. This support Malaysia's move toward cleaner and more efficient energy generation. For lastly, conclusion. In conclusion, coal-fired power plants play a major role in our energy supply, but they also can create environmental challenge. By applying technologies such as electrostatic precipitators, scrubbers, cooling towers, and ash recycling system, we can minimize pollution and move closer to sustainable energy goals. As future engineers, it's our responsibility to design systems that balance every demand with environmental protection. Thank you for listening, and I hope this presentation helped you understand how we can make goal energy cleaner and more responsibility. That's all from me. Thank you for watching my presentation, environmental control strategy for coal-fired power plant. Have a great day, and please leave a like, and thank you all. Bye.